Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for few questions which are given in previous NEET exams. The chapter name is Newton Laws of Motion. This is given in 2016. A car is negotiating a curved road of radius capital R. The road is banked at an angle theta. The coefficient of friction between the tires of the car and the road is mu s. S is subscript. The maximum safe velocity on this road is. Okay, let us try to understand. So whenever the car is moving along the curved path, so let us say your car is on the highway moving with the maximum permissible speed. So whenever it comes to the place of curved road, so the vehicle, in general, you observe that vehicle will not be almost at the not on the horizontal surface. So vehicle will come across somehow inclined surface. So vehicle is not on this horizontal surface. Vehicle is somehow on the inclined surface. So that is why. So while going on the curved surfaces, we observe some light upliftment, maybe inwards or outwards. So when the vehicle is on this inclined surface, so its weight acts vertically downwards. You might know normal reaction is perpendicular to the surface of contact. So this is surface of contact of your vehicle. So this is perpendicular. Now, the component of normal reaction. If theta is taken here, the component of normal reaction will be n cos theta. So n cos theta is equal to mg now. So other components act straight away towards the center. So that is, you call it as n sin theta. Then next. So simultaneously there is also action of the frictional force along the surface of the contact. So in general, frictional force we call it as tangential force. So frictional force acts along the surface of contact. So even frictional force is also making an angle theta. So therefore, frictional force will have two components. So its component F cos theta acts towards the center. So other component will be joined with the weight of the vehicle. So now let us list out the forces which are acting towards the center, which are balancing the component of normal reaction. First, n cos theta is equal to mg plus f sin theta. So since it is frictional force, so you might know frictional force is directly proportional to normal reaction. On removal of the proportionality, you will get coefficient of friction, that is static friction. Okay, so therefore, mu s n with sin theta mg is equal to n cos theta. So take mu s n left side. So afterwards you can take out common n. So you will get cos theta minus mu s sin theta is equal to mg. Call this the equation 1. Next. So the component of frictional force and the normal reaction are acting towards the center. So they both are equal to, the combination of these two forces will be equal to centripetal force. So therefore, n sin theta plus frictional force component F cos theta is equal to centripetal force. R is the radius of the curved path. So once again, n sin theta plus this is going to be mu s n cos theta is equal to mv square by r. Call this the equation 2. Then okay, in case you can take here n common once again to write another step. N sin theta plus mu s cos theta is equal to mv square by r. So this is not the new equation. So if you divide equation 1 and 2, so divide 2 with equation 1. So you'll get mv square by r by mg is equal to n of sin theta plus mu s cos theta whole divided by, so the first equation is having left side n of cos theta mu s sin theta, n of cos theta minus mu s sin theta, n and n get cancelled, m and m get cancelled. So you'll finally get v square equal to this r and g get multiplied, take the right side rg. So this is sin theta plus mu s cos theta whole divided by cos theta minus mu s sin theta. So if you cancel, this entire quantity will come under this. So even you can take out common sin theta. Even you can take out common sin theta. Yeah. So if you take out common sin theta, you'll get rg. So if you take sin theta common here, you'll get first one plus mu s. This is going to be, okay, you take cos theta common better. Cos theta common. So it will be sin theta by cos theta plus 1 plus mu s, whole divided by within the root. So cos theta you are taking out common. So here 1 minus mu s sin theta by cos theta. So therefore, this is tan theta, cos theta get cancelled. You'll finally get rg of tan theta plus mu s whole divided by 1 minus mu s tan theta. So last option is correct. Moving to the next question. So this is the question which is based on change in the momentum. Yeah. So this is the rigid wall. Ball is hitting the wall at an angle 60 with the normal draw. So ball will have its component. So let us say this is V sin theta. So V is resolved into two components. So this is going to be, because this acts as adjacent. So therefore this is going to be V cos theta. After hitting the wall, again it is given 60. So after hitting the ball, there is again V cos theta. So the V cos theta before incidence, V cos theta after incidence, the direction is opposite. So therefore, so let us say the question is impulse. Impulse is numerically equal to change in the momentum. It is mv minus mu. So this is after, this is before. This is the direction of velocity before and after opposite. So therefore, keeping that in mind, V cos theta they mentioned, and going back with the same speed. So therefore, V and V. So you can mention that V is equal to minus U, but they mentioned in the question, this is also, U is also V. So therefore, minus in the formula, minus with the sign convention. So therefore, V cos theta, initial is also V cos theta. So therefore, together you'll get 2mv cos theta is equal to, what is theta? Theta is 60 now. So 2mv cos 60 is 1 by 2. It cancels. So the answer is mv. First option is correct. Moving to the another question. Yeah. Question number 3. This is given in 2017. One end of a string of length L connected to a particle of mass m, and other end is connected to a small peg. So let us say small peg with small pin. So this is, you can understand with the help of diagram like this. This is a pin or peg. Okay. So if the particle moves in the circular circle with the speed v, the net force on the particle, so directed towards the center. So while moving in the circular path, then so tension is always every time is balanced with the centripetal force. So tension is playing a role like centripetal force. So don't assume the existence of both. So tension is acting like a centripetal force. So magnitude of the tension is equal to magnitude of the centripetal force. Yeah, so option 4 is correct. Moving to the another question. Yeah. So two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible spring. The whole system is suspended by a massless spring as shown in the figure. Magnitudes of the accelerations A and B immediately after the string is cut. Suppose before the string is cut. Before the string is cut, let us draw the free body diagram first. So this is the rigid support. This is the spring. So there is string here. This is spring. This is string. So the string is connecting M. If this is cut, so before cutting, so this is 3m means its weight acts vertically downwards. So this is 3mg. Then, so there is mg here. So in order to balance, in order to hold the mg, there should be tension. So this T before the string is cut, for m, T is equal to mg. Whereas when you talk about before the string is cut, when you talk about the forces acting on 3m, so tension is playing in opposite direction to mg, whereas tension favors this mg. So these two, this 3mg and the tension is equal to the strength of the spring. So what is the force? Spring force. Spring force is equal to kx. They both are equal to tension. This is all before cut. 3mg. This is before cut. Now, suppose if you substitute kx is equal to T is mg. So mg plus 3mg. They both are equal to 4mg. Next. So this is before cut, after cut. So after the cut, so anyhow the block of mass m moves with acceleration due to gravity. There is no issue because it is freely falling. This is block B, you call it. So this is acceleration of block B. Now whereas acceleration of block A, so acceleration of block A, so kx and weight, kx is 4mg, kx and weight of 3mg, the weight of 3mg acts downwards, kx minus 3mg, you are talking about its mass. So therefore this is going to be 3m. So kx you got 4mg, this is 3mg by 3m. So therefore this is mg by 3m. So m and m get cancelled. So acceleration of block A is g by 3. So first option is correct. Next question number 5. Which of the following statements is incorrect? So rolling friction is smaller than sliding friction or kinetic friction. Yes, rolling friction is smaller than kinetic friction. So you can understand that the theory point is static friction is greater than kinetic friction or sliding friction, which is greater than rolling friction. So definitely, so rolling friction is smaller than. You say static kinetic friction is greater than rolling means what? Rolling friction is smaller than kinetic friction. So this statement is okay. Limiting value of static friction is directly proportional to normal reaction. So any friction is directly proportional to normal reaction. So this is also correct. Frictional force opposes the relative motion. So this particular statement is involved in the definition itself. Coefficient of static friction has dimensions of length. No. So coefficient of friction is dimensionless constant because it is static friction by normal reaction or kinetic friction by normal reaction or another one rolling friction by normal reaction. Even there is one more friction between static and kinetic, that is limiting. Even limiting friction by normal reaction also you can get. So this is force. This is another way of force. Force by force. So there is no question of existence of units or dimensions. So therefore coefficient of friction is dimensionless. It's not having the dimensions of length. So therefore this statement is wrong. Fourth option is correct. Yeah, moving to another question. Question number 6. So this is given in 2018. A block of mass M is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration towards right. So the relation between A and theta for the block to remain stationary on the wedge. Yeah. So let me draw the diagram. So block of mass M is on the inclined plane. So don't forget to take the resolution. Mg acts vertically downwards. So this is going to be the normal reaction. In case theta is taken here, this is going to be n cos theta. Now, so there is another component of normal reaction is n sin theta. So wedge is given an acceleration here. So there will be pseudo force on block of mass M. So therefore, so this is going to be pseudo force on block of masses Ma. So now n cos theta is equal to mg. So when the block of mass M is stationary, wedge is moving, but block is stationary. So this is the condition to be written. N cos theta is equal to mg, and n sin theta is equal to m. So you call this equation 2. This is equation 1, dividing 2 with 1. So n sin theta by n cos theta is equal to ma by mg. These two get cancelled. N and n get cancelled. So therefore, sin theta by cos theta. So sin theta by cos theta is tan theta is equal to a by g. So a is equal to g tan theta. So last option is correct. Moving to the next question. This is once again theory, but this is given 2019, question number 7. A particle moving with velocity v is acted by three forces shown by the vector triangle PQR. The velocity of the particle. So remember, the sum of three forces or three vectors is equal to 0. So let us say this is F1 acting along PQ, F2 along QR, and F3. F3 is along RQ. This is equal to 0. This is also equal to net force. So net force is equal to 0. So get back, net force is equal to Ma. When net force is equal to 0, so acceleration will also be 0. So when body is moving with a constant 0 acceleration, so body moves with uniform velocity. So what is the reason to say is A is equal to the basic fundamental equation of motion. So if A is equal to 0, V minus U by T. So therefore this is going to be finally V equal to U. So when acceleration is 0, initial velocity equal to final velocity. So therefore body moves with a constant velocity, or its velocity remains constant. Fourth option is correct. Moving to the another question. So this is given in 2000. The block of mass 10 kg is in contact the inner wall of the hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical, and rotating about its axis. So just you understand that. So this is the cylinder. A block of mass 10 kg is in contact with the inner wall. So let us say this is the axis about which a cylinder is supposed to rotate. During the rotation, so always remember normal reaction acts perpendicular to the surface of contact. So this is surface of contact. Normal reaction acts towards the center. So therefore, this normal reaction is playing a role like centripetal force. Yeah, then this is equal to. So there is weight acts vertically downwards. If you want this block of 10 kg not to fall down, so you have to rotate the drum with the uniform angular velocity. So therefore, since friction acts along the surface of contact, so therefore you take friction is balanced, static friction only. So when net force is 0, static friction is equal to mg. So what is static friction? So it is mu s into n, that is equal to mg. So what is normal reaction? That is mv square by r is equal to mg. You can cancel m and m. So you can continue this one as, so your mu s is given in the question 0.1. Then you change this v as v is equal to r omega. In rotatory motion, the relation between tangential velocity and angular velocity v equal to r omega. So that r square omega square by r is equal to g. Okay, so 1 r get cancelled. So this is going to be 0.1. How much is r given in the question? R is given 1 meter. Yeah, this is 1 meter with omega square is equal to g. So g is 10. Okay. So if you take this down, you'll get omega square equal to 10 by 0.1. So if you cancel point, this will be 100. So you'll get omega as 10 radian per second. So 10 radian per second means, so last option is correct. Moving to the another question. Question number, this is 8. Now proceed to 9. Yeah. So basic NCERT textbook question. This is given in 2020. Two bodies of masses 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless, which is shown in the figure. The acceleration of the system in terms of acceleration of g. Okay, so directly you might have read the formula, you might have practiced the formula. A is equal to whichever greater, m2 minus m1 with g divided by m1 plus m2. So you refer NCERT textbook for the formula derivation. M2 is 6, M1 is 4. This is G because options are given in terms of G only. So M1 is once again 6, M2 is 4. So this is okay. This is 2G by 10. So therefore, answer is G by 5. So third option is correct. Moving to the question number 10. Okay, so this is, since motion is inclined plane, this is included in this chapter. But actually, strictly speaking, this particular question to be explained in motion in straight line. A small block slides on a smooth inclined plane starting from west t equal to 0. Sn is the distance covered, distance traveled by the block in the time interval t equal to n minus 1 to t equal to n. The ratio of Sn by Sn plus 1. So distance covered in a particular second, this you have learned A of n minus half. So therefore, the mention starting from west means u0. So you'll get Sn is equal to A of n minus half. Suppose if you simplify further, there is a chance 2n minus 1 whole divided by 2. This is Sn. But the question is Sn plus 1. So what you need to do is, in place of n, you substitute n plus 1. So A of n plus 1 minus 1 by 2. If you simplify this, this is 2n plus 2 minus 1 whole divided by 2. So therefore, A of 2n plus 1 whole divided by 2. So first and second are divided. Sn by Sn plus 1 is equal to, Sn is A of 2n minus 1 by 2 divided by Sn plus 1 is 2n plus 1 by 2. A of 2 cancel, A cancel. So therefore, 2n minus 1 by 2n plus 1. So second option is correct. Moving to the another question. A ball of mass 0.15 kg is dropped from a height of 10 meters, strikes the ground and rebounds to the same height. So you need to find out magnitude of the impulse imparted to the ball. So let us say this is the horizontal surface, or you can say this is the ground. So ball is dropped here. The initial velocity you take it as 0. Final velocity at the time of hitting the ball is u1. So covering the distance 10 meters. You treat it as h1 is equal to 10 meters. Then in general it travels along the same path. For the sake of understand, most of us we just draw the diagram like this. So just you try to understand, it moves up along the same path. So covers the same distance in vertical motion also. So you call h2 is equal to, but of course, once it reaches h2, final velocity becomes 0. Assume that the upward motion is started with initial velocity v1. So h2 is also equal to 10 meters. So impulse is numerically equal to change in momentum. So you treat this is v1 after hitting, before hitting u1. Yeah, so make use of v square minus u square equal to 2as. So initial velocity is 0, final velocity is u1 square is equal to, since it is coming down, minus g, this is minus 10 h1. So just you take it as 2a h1, 2g h1. So minus minus, so therefore u1 is equal to, this is 2 into 10, so this is 100 and 200. u1 square is 200, so you make it, this is root 200, so this will be 10 root 2 meters per second. So this is u1. Similarly, while going upwards, final velocity 0 starts with initial velocity v1 square. Since going upwards, minus g permanently negative, but h2 is positive, but that is 10. So minus minus cancel. So you will get v1 is equal to also root 200, but this is also 10 root. Now formula. So m1 is 0.15 kg. M you can take out common. The direction of v1 and u1 are opposite. So therefore, v1 minus of minus u1. So you'll get 0.15. v1 is 10 root 2 plus u1 is also 10 root 2. So therefore, finally you'll get, this is root 2 you can take out common. Then this will be 20 root 2. So therefore, 0.15 with the root 2, 10 plus 10, 20. So if you simplify, you'll get the answer 4.2 kg meter per second. So second option is correct. Moving to the another question. Yeah. So in the diagram shown, the normal reaction between 2 kg and 1 kg you need to consider, you need to find out. So draw the inclined plane. So all bodies are in contact. So this is 30. So this is 3 kg block. So thereafter you have 2 kg block. Thereafter you have 1 kg block. So there are two forces acting, 18 downwards and 60 upwards. Okay, so we can list out the contact forces also. So first, don't forget to have the resolution. So for all the bodies, it will be mg sin theta to act downwards. So therefore, this is 3mg sin theta. Then, so this 3mg sin theta opposing 60, but favoring 18. Next, so here, contact force favors the motion of 3 kg, but opposes 3 kg. So this is here first contact force, mg sin theta. Then contact force favors, contact force opposes. Contact force 2 kg, but contact force opposes. Next step, 3 kg. Then here contact force favors 1 kg, contact force opposes 2 kg. So therefore, we are going to find out normal reaction with contact force between 2 kg and 1 kg. Okay, so let us try to find out. First, acceleration of all the bodies. Now 60 is opposed by 18. So opposition in combination plus 3 mg. So 3 already 3 kg given. You can write 3g sin 30 plus 2g sin 30 plus 1g sin 30. Or otherwise you can write g sin 30 whole divided by even, okay, 18 already written. So divide by total mass. 3 plus 2 plus 1. So it is 6. So acceleration is the acceleration of the system. 60 minus, this is going to be 18 plus, so this is 3g. 3g is 10 with 1 by 2 plus 2g with 10 with 1 by 2 plus g with 1 by 2. So otherwise 10 into 1 by 2. Whole divided by 6. So this is 5. This is 5. This is 5. So therefore 60 minus 18. 18 plus 15. 18 plus 15 plus 10 plus 5. Whole divided by 6. So therefore this is going to be 33, 43, 48. So 60 minus 48 whole divided by 6. So this will be 12 by 6. So combined acceleration is 2 meter per second. Now moving to the contact force. Yeah, look at the diagram. The motion of 1 kg body upwards is only because of its contact force, but simultaneously it is opposed by its weight component. So anyhow, by default, weight component for all the bodies acts downwards only. Also, this mg sin theta is associated with 18. So therefore, we are looking for contact force. This is the reason to go upwards, then which is opposed by component of its weight mg sin theta minus 18 is equal to its net force. In case net force is present, there is a chance to get acceleration. So F we are looking for, m is 1, this is 10, 1 by 2 sin 30 minus 18 is equal to 1 is its mass, acceleration is 2. So therefore, this is a 5. So F is equal to, this is minus 5 minus 8 is 23, taking right side, 23 plus 2. So 25. Stop, it is correct. Moving to the next question. So this is given in NEET re-exam. So the distance covered by a body of mass 5 grams having linear momentum 0.3 kg meter per second in 5 seconds. Moving to the last question. This is given in the re-exam, which you sent us NEET 2022 conducted again. The distance covered by a body of mass 5 grams having linear momentum 3 kg, 0.3 kg meter per second in 5 seconds is. So distance you need to find out. So to find out distance, first you find out with what velocity it is moving. So momentum is equal to mv, linear momentum in particular. So 0.3 is equal to m is 5 grams, convert into kg with velocity. So therefore, velocity is equal to 0.3 by 5 into 10 to the power of minus 3. So to get the distance, so you can make it as a distance is equal to velocity into time. So velocity is 0.3 divided by 5 into minus 3. So in the question, time mentioned as 5 seconds. So 5 and 5 cancel. So this is going to be 0.3 into 10 cube. So it will be 300 meters. So first option is correct. Students, in my next video, I'll continue the explanation of previous NEET questions in the chapter Work Energy and Power. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.